Hello children, I am Shishmita and today interpreting with me is Hemalata. And welcome back for a new session. You might have very often heard or even used statements in daily life like he is more energetic or I am so tired and lost my energy or today I am feeling more energetic than yesterday, etc. What is this energy? How can we decide that an object possesses energy or not? Let's go in search of these answers in a scientific manner. Learning outcomes. At the end of this session, you will be able to understand about definition of energy, types of energy, kinetic energy, expression of kinetic energy, potential energy, mechanical energy, conservation of energy. Keywords: work, energy, kinetic energy, potential energy, mechanical energy. Concept map. For example, let us consider the following two cases. Case number 1. A metal ball that was kept on a ceramic plate is raised to a certain height from the plate and allowed to fall on it. Case number 2. A toy car was placed on the floor without winding the key attached to it, and the same toy car is placed on the floor again after winding the key attached to it. Let us find out that if any energy is used in these two cases or what type of energy is used. Energy is related to work done. The capacity of doing a work by an object on another object depends on the position and state of the object which is doing the work. Thus, an object acquires energy through different means and is able to do work. In science, we consider work has been done only when there is a change in the position of the object. The object is able to change its position due to the energy transferred to it by the force doing the work. Thus, whenever work is done on an object, its energy either increases or decreases. The capacity of body to perform work is called its energy. In the definition of energy, we can say that the capacity of body to perform a work is called its energy. The units of work and energy are the same. The unit in the SI system is joule, while the same in the CGS system is ERG. Energy exists in various forms like mechanical, heat, light, sound, electromagnetic, chemical, nuclear, and solar. In this chapter, we are going to study two forms of mechanical energy, namely potential energy and kinetic energy. A fast cricket ball strikes the stumps. The striker hits a coin on the carom board. One marble strikes another in a game of marbles. From the above examples, we understand that when a moving object strikes a stationary object, the stationary object moves. Thus, the moving object has some energy, part or all of, which it shares with the stationary object, thereby setting it in motion. We can define it like the work done by a force to displace a stationary object through a distance S is the kinetic energy gained by the object. We know that the kinetic energy of a body at rest is 0. But the kinetic energy of a body moving with certain velocity is equal to the work done on it to make it acquire that velocity from rest. Let us assume that an object of a mass m is at rest on a smooth horizontal plane. Let it be displaced through a distance s from the point A to B by a force F acting upon it in the direction of the displacement. In the horizontal direction, the net force F net is equal to the applied force F. So, the work done on the object by the net force is F net into S. Let the work done on the object cause a change in its velocity from u to v and the acceleration produced be a. We have studied about the equations of uniform accelerated motion. The relation between initially velocity u, final velocity v, acceleration a and displacement is s is given by v square minus u square is equal to 2as. It can be represented like this also. We know from Newton's second law of motion that F net is equal to ma. Combining equations 1, 2 and 3, we can write these equations. This is called the work energy theorem. As we have assumed that when an object is at rest, its initial velocity u is equal to 0, then w is equal to 1 by 2 m v square. Thus, the work done on the object is equal to 1 by 2 m v square. We know that kinetic energy of a body moving with a certain velocity is equal to the work done on the object to acquire that velocity from its rest. Thus, the kinetic energy Ke possessed by an object of mass m and moving with velocity v is equal to 1 by 2 m v square. An arrow is released from a stretched bow. A compressed spring is released. Which words describe the state of the object in the above examples? Where did the energy required to cause the motion of objects come from? Let's learn about potential energy now. We can define that the energy stored in an object because of its specific state or position is called its potential energy. To carry an object of mass m to a height h above the Earth's surface, a force equal to mg has to be used against the direction of the gravitational force. The amount of work done can be calculated as like these. So, the amount of potential energy stored in the object because of its displacement P dot E dot is equal to mgh. Displacement to height h causes energy equal to mgh to be stored in the object. The sum of the kinetic energy and the potential energy of an object is called its mechanical energy. Let's consider an example. The kinetic energy of an aeroplane at rest is 0. Its potential energy when it is on ground is also considered as 0. Thus, its mechanical energy is 0 while its rest on the ground. When the same aeroplane flies, it has kinetic energy as well as potential energy. The sum of these energies gives the total mechanical energy of the aeroplane in flight. In nature, we find a number of instances of conversion of energy from one form to another form. Sun is the big source of energy in nature. The solar energy from the sun is converted into various forms like light energy, heat energy, wind energy, etc. Apart from this, we observe various instances of energy conversion in our day-to-day activities like the conversion of electrical energy into heat energy by iron box, chemical energy into light energy by a torch, etc. Thank you for watching this video.